keep on going. Reducing fractions and equivalent fractions. We talked about reducing it. In order to reduce a fraction, we're going to divide the numerator and denominator separately by a common factor. It doesn't have to be the greatest common factor. My suggestion to you guys would be to start small, because you can always just divide by 2 multiple times, and that'll eventually get you to the answer. Here, we saw before that 3 goes into both of these. 3 is a common factor, so this thing is 1/3. In order to reduce a fraction, divide the numerator and denominator by a common factor. Okay. Let's do the first 4 here. Think of a common factor that goes into both 10 and 5. 5. So when I do this, divide by 5 on top and bottom, 10 divided by 5 is 2, 5 over 5 is just 1. But remember that we can write this as just 2. No problem. What would be a common factor of 18 and 10? 2. 9 over 5. Now, turn that into a mixed fraction. Awesome. 1 4/5. Be very, very careful in the computer on the homeworks, because it'll say write as a whole number, write as a proper fraction, or as a mixed fraction. Which means if you put 9 over 5 as the answer, you will get it wrong. It's one of those things. You got to write it as 1 4/5. Common factor of 64 and 16. 4 goes into it, sure. Can we go further? And then 2, how about that? 16 divided by 2, 4 divided by 2. Can we go further? So that's what I mean by starting with small numbers, right? Because you just keep going and eventually you'll get to the right answer. It turns out that 16 is a factor of 64. How about 100 over 6? Sure, divided by 2 again. Ooh. Let's write this as a mixed fraction. How many times does 3 go into 5? 1. And then 3 times 1 is 3. Subtract. So that's 2. Bring down the 0. How many times does 3 go into 20? 6 times. 6 times 3 is 18. 20 minus 18 is 2. So that's remainder 2. Okay, remember that, I'm just highlighting a few things just to be real specific. Remember that the remainder is the numerator. The quotient is the whole number. And the divisor is the denominator. There you go. Questions or comments on reducing? Okay. It says write the prime factorization of the numerator and denominator. Then write the fraction in simplest terms. Okay, so I will do this. If you do your factor tree and things like that, you'll realize that you can write 24 as 2 times 2 times 2 times 3. 48 will end up breaking down to 2 times 2 times 2 times 2 times 3. So why am I writing it out like this? We can cancel factors in the numerator and denominator. What do I mean by canceling? I'm just going to go like this. Okay, I got a 2 on top and a 2 on bottom. Done. I got another 2 and another 2. And you keep doing that. Three and a 3. So this whole thing can be broken down into what's going to be on top. There's nothing there, but you still have to imagine that there's a 1. So it reduces to 1/2. It's just another way to think about it, that's all. You'll see that when we get to multiplying fractions. I'm going to bypass that one for now. If you ever want me to go back or you want another example or anything like that, just let me know.
Actually, yeah. Do an example where, like,
Sure. Let's see, what do I think about? Um, $40 over $2.10. Okay? You would do your factor tree and everything. Okay. But if you think about it, 40 is 8 times 5, and then 8 is 2 times 2 times 2. Okay. So this prime factorization would be 2 times 2 times 2 times 5.
So basically, anytime it asks for the product of a prime factorization, it's asking you to write it out like that, or just and simplify.
Yes.
Okay.
It may, you'd have to check in the homework, but it may be looking for this, 2 to the third times 5, if you remember doing that on the test.
Okay.
It might ask for that too.
Got it.
210. Just throw that up real quick. Be 21 times 10, 3 times 7, 5 times 2. Okay, so now the bottom one would be 2 times 3 times 5 times 7. So what cancels?
2 and 5.
Right. So I've got a 2 and a 5. This thing should reduce to 4 over 21. Because think about it. 2 times 2 is 4. And 3 times 7 is 21. All right? It's like chapter 1 and chapter 2 put together. Find the missing numerator. Ask yourself, what do I have to multiply the 3 by and the 4 by? Because remember, we said what you do to the top, you got to do to the bottom. So how can I go from 4 to 12? Times 3. So what you do to the top, you have to do to the bottom. I think that x will be equal to 3 times 3. Don't add. Right. So that's how you do that. You notice how the same rules apply. How about b? B is equal to. Eight times what number? 5 times what number will give me, got it? 32. Yeah. So z is 32. My man. No good? Yeah, sure. If I multiply 5 times what number will give me 20? Yeah. So go back to your rule. What you do the top, you got to do the bottom. So then it's got to be 8 times 4 would give you 32. If you want to think of it backwards, well, 20 over 32, reduce it. I can reduce it by dividing by 4. Gets me back to the original. that multiplying and combine numerators with numerators and denominators with denominators. In other words, multiply straight across. Three times 5 is 15. 5 times 4 is 20. Now reduce. What is the number that goes into both 15 and 20? 5. Now, why am I throwing this one at you? 8 over 12 multiplied by 12 over 7. You get a pretty big number there. 8 times 12 is like 96. And 12 times 7 would be 84? Yep. Okay, but I see a much easier way, though. Because remember how we can cancel things if they're on the top and bottom when you multiply? So why don't I just do this? And write it as 8 over 7. I don't care how you do it. If you get 96 over 84, well, you're just going to go through the same process. And you end up dividing. You would do divided by 12 would be a factor, and you'd end up getting the same thing. Then they throw three things at you. 15 times 6 over 24. I will do the first one. I think that I can now reduce not just the 10 and the 4, but like the 4 and the 12. Because it's all being multiplied together, right? Well, if I divide 12 by 4, I get 3, and this turns into a 1. Now, what's a common factor of 10 and 15? 5. So 10 divided by 5 is 2. 15 divided by 5 is 3. Now let's reduce 6 and 24. And it still reduces. So 2 times 3 is 6. 3 times 4 is 12. That reduces again. The whole thing boils down to 1/2. It's not easy when you first see it. You know. You could. Sure. Nope. Part of the reason why it's difficult, because there's like 3 or 4 different ways to do it. You should get 1/2 no matter what you do. All right, let's do it. Let's do a different way for b. Let's say that I just multiplied straight across. All right. Now I have to imagine that this is 4 over 1. So I'm going to do 4 times 8 times 18. And I get 576. Then on the bottom, I have to do 1 times 9 times 24. 216. Well, I got this huge fraction, but just start with a common factor that you think goes into both of them.
2.
Would be 2. That's the easiest thing, because they're both even. $108. $288. They're both even again, right? So we can divide by 2. But I'm one of those crazy thinkers, right? So you know that if the last 2 digits of a number are divisible by 4, then the whole number is divisible by 4. So I know that 88 is divisible by 4, and 8 is divisible by 4. So I think I can pick a factor of 4 for these. I hope. Not done yet. 72 and 27. 3 will go into that. All right, I don't think there are any more factors. Are there? Oh, there is. Yeah, you can do 3, right? Ooh. 8 over 3. There we go. I feel your pain. I throw those big numbers at you. All right, a couple more. of $72,000. 1/3 is spent on housing. 1/12 is spent on groceries, and 1/8 is spent on utilities. The simple question that they ask you is, how much money is spent on housing? And the way that you would solve that is to find that portion of the total 72,000, but divide it into 3 parts. So what I can do is 72,000, you can think of it as just divided by 3. Or times 1/3. Which would be 24,000. Okay, so just break it up into that part. I'm going to pass over that for now. You have a total of $72,000, right? If you spend 1/3 of your money, well, divide it by 3. Dividing by a fraction is the multiplying by the reciprocal. Reciprocal means flip the fraction. Example. Reciprocal of 4. You would flip that into a fraction and write it as 1/4. Because remember, you can write it as 4 over 1. So it's just flipping it. So what I will do here in order to divide fractions, dividing is the same as multiplying by the reciprocal. So this is called keep the first, change to multiplication, and flip the second fraction. I don't know if any of you have ever heard of it. Keep, change, flip. Keep the first, change it to a dot, and then flip the second. So 3 times 3 is 9. 5 times 8 is 40. And does that reduce?